All right. Hi, everyone. So we are going back to similarity today. So you should be in your Unit 5 blank notes. And we are on Lesson 3. Okay, so we would have done Lessons 1 and 2 at the beginning of last week. And just to review, if I flip back a little bit, here we go, flipping all the way back. Okay, in Lessons 1 and 2, we were looking at what is similarity. What do we know about similarity? Okay, so similarity is when shapes look the same, but they're a different size. So the side lengths would be proportional to one another. All of the angles would be equal. Okay, we looked at how do we find side lengths on a similar shape if we know that two shapes rather are similar. So we looked at a problem doing that. We also figured out how do we find out the value of corresponding angles if we know that two triangles, for example, are similar, right? And we know that their corresponding angles must be equal. So this is all stuff that we would have done last week. And then we also looked at if we have a model, let's say, if we're doing a model of a house, how could we find out what the size of the model would be? Okay, so those are a few things that we did. We also looked at how could we tell if we have two shapes if they are similar? Okay, and a couple of things that we have to look for. Firstly, all of the sides must be proportional to one another. And secondly, all of the angles must be equal to one another. And we must know both of those things. Okay, so that's just a little bit of what we've done so far. Okay. Today, what I'd like to talk about is scale factor. Okay. And a scale factor is essentially when we have a figure and we want to increase the size or decrease the size. Okay, we want to scale it up or we want to scale it down. Okay, the scale factor is the amount that we would multiply each side by of the original to produce a similar figure. Okay, so when we scale up or scale down a figure to produce a similar figure, we multiply all sides by the same amount. Okay, and this is called the scale factor. Okay, and in fact, I'm just going to move this, whoops, I got to go to here. I'm going to move this over a little bit. The scale factor is equal to basically the new diagram over the original diagram. Okay, so, or if you're doing like a model, it would be the model over the original. So if you think about maybe building perhaps a model of a building, if you're an architect, okay, or maybe you're making a model of the Empire State Building out of Lego or something like that, okay? So it's the model over the original, okay? Or you could think about it as the new diagram over the old diagram or original. Okay, and we're going to see what that looks like in a second. All right, so what we're going to do first is we're going to look at this diagram, and we're going to use the graph paper below to draw one that is exactly 1.5 times the length of the original. So this is our scale factor here. In this case, our scale factor is 1.5 or 1.5. What that means is that we need to multiply all of the original side lengths by 1.5. And when you are doing this, precision is incredibly important. So you need to make sure that you are counting very, very carefully exactly how long each side is. Okay, so what I'm going to do is I'm going to start here, and I'm going to say, okay, from this corner to this corner, that's 1, 2, 3, 4, 5, 6. That's exactly 6 little blocks. Okay, and from here to here, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, and I'm going to do all the straight ones first. So from here to here, this is 1, 2, 3, 4. So that's 4. Okay, and then these ones, I'm going to kind of do them on the diagonal. So if you look, these are almost like the hypotenuse of these little squares. So 1, 2, 3, 4 diagonals. So I'm going to write that as 4 diagonals. Okay, and then this over here, these are also diagonals. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 diagonals. Okay, now what I need to do is I need to multiply all of those values by 1.5 to get my new diagram. So if I start with the 6 and I go 6 times 1.5, that's equal to 9. And then if I go 4 times 1.5, that's equal to 6. And then I'll do the same thing. So I'm starting down here and I'm just working my way around. 4 times 1.5 is also equal to 6. And then 10 times, and by the way, this first 4, right? So I go this 6 over here, and then this first 4, these are like diagonal. Whoops, diagonal. And then this 4 over here, the second one, that's just straight across. Then I've got 10 times 1.5, and that's equal to 15, and that's diagonal. Okay, and then I've got 18 times 1.5, and that's equal to 27. Okay, and then what I can do is I can start to draw my new one. And I apologize, I didn't give you guys enough squares when I did this, but I'm going to start in this very bottom corner here, and we'll just have to do like an estimate. So my first one that corresponded to the side that was 6, that has to go 9 up. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And then the second one was 4 diagonals. That has to become 6 diagonals. So 1, 2, 3, 4, 5, 6. Okay. And then the next one, so I'm doing this one over here, that's 6 across. 1, 2, 3, 4, 5, 6. Okay, and then 15 diagonals. So I think this is where I didn't give you guys enough room. I'm sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so here we're just going to have to pretend that we can estimate. 10, 11, 12, 13, 14, 15. So that's 15. And then 27 across. Well, here actually we can just connect the 2 endpoints, and that should be exactly 27. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, now if I just kind of imagine 21, 22, 23, 24, 25, 26, 27. There we go. Okay, and so if you just label these sides, this is the 9, this is the 6 diagonal, right? This is the 6, this is the 15 diagonal, and then this is the 27. Okay, so it's really important when you're drawing these scale diagrams that you're very precise and that you do this work over here and you actually count carefully and you don't just do kind of a rough estimate with your eyes. Okay, all right, now the last example that I want to do is an example where we have to figure out what scale factor was used. So Barney's house is 55 feet wide and 40 feet deep. A drawing of his property shows the house is 10 inches wide and 7.3 inches deep. What scale was used on the drawing? Okay, so what scale was used on the drawing? So the scale factor is always going to be like the scale diagram over the original. Okay, so if you think about the drawing, right, and we're comparing the corresponding sides, so width to width and depth to depth. So for this, for the scale, maybe I'll use like a little lowercase w for the 10 inches and a lowercase d for the depth. And for the house, the actual house, I'll use an uppercase W and an uppercase D. Okay, now if I'm looking at the fact that the scale factor is the scale diagram over the original, okay, or the new over the original, then the drawing is the new and the actual house is the original. Okay, so what I'm looking at, if I'm comparing width over width, right, because this is the smaller case w, the lowercase w is the drawing, so that's the new or the scale diagram over the original is the actual house. That is 10 over 55. Okay. And if you actually put that into your calculator and figure out what that is as a decimal, then what you're going to get is, just doing it right now, about 0.18. Okay, now what you want to do though is you want to make sure it's the same if we compare depth to depth. So if we do it using the depth to depth, right, that's 7.3 over 40. And if I divide those, I'm just doing this on a calculator now. You guys can't see this, but you could do it on a calculator. I also get 0.18, okay? So to get the 0.18, remember fractions are division. So I just went 7.3 divided by 40, and that gave me the 0.18, okay? So this is the scale that was used on this drawing, okay? You could also reduce this fraction if you wanted. So if you wanted to use the 10 inches to 55 feet, right? You could also say, or something like 1 inch equals 5.5 feet, right? Because if 10 inches equals 55 feet, just divide them both by 10, and you get 1 inch equals 5.5 feet. But if you go 1 divided by 5.5, you're still going to get that 0.18. Okay, so that's going to be the end of this video. And and I will catch you guys next time.